Recording has started.
Have you guys make sure you've got your microphones muted if you're at home?
One thing, Mr. Hawk, before you start in,
Yeah, David.
I'd like to say something that somebody kind of forgot to clean out the spray gun today in class.
The
Just
paint
wanted to
booth.
put out the info.
I'm sure you guys will be hearing about that in the next class. Okay, so today we're going to look at the next type of use of a variable, and that is in things that look like this. A variable equals a number. Now this, of course, is called an equation, and it's named that after, of course, this symbol here, the equal sign. And I ask people to define what that equal sign means, and a lot of people have a hard time defining it without actually using the word equals. Well, what it really means is what's on one side of it has exactly the same value as what's on the other side. In fact, we can think of it as being a scale that balances around that equal sign. Now, this is a pretty simple equation. We're used to seeing them probably way more complex than that. But all equations start in this form. In that form that is a variable equals a number or a number equals a variable. And then they are built from there. And they're built with our basic math operations. Now we've seen 6 operations so far. Remember, they all come in pairs, the inverse pairs. We have addition and subtraction. That's one of our pairs. Multiplication and division. That's another pair. We've had powers and roots, our exponents. That's a third pair. There's other pairs that are out there, exponentials and logarithms. There's trigs and their trig functions and their inverses. We're not, obviously haven't covered the exponentials, logarithms, or the trig functions yet. And for right now, we're not going to look at the exponent or the powers and roots quite yet. So we're going to stick to our big 4 for building onto our equations. So to build a more complicated equation here, let's try to add 4 to it. So instead of just x now, that's x plus 4. However, if I do that, if I add x to one side, my equation, my scale isn't going to balance anymore. Keep that scale balanced, whatever I do to one side, I have to do exactly the same to the other side. So I have to add 4 to the 7 as well, which would make it 11. So we have now built a more complicated equation. But we are typically not asked to build equations. We are typically asked to solve equations. And when we're asked to solve an equation, what we're really being asked to do is to take it back apart and get it to that form, that starting form of a variable equals a number. So this equation here was built by adding 4. Take it apart, we're going to do the opposite. The opposite of adding 4 would be subtracting 4. Remembering that whatever we do to one side, we got to do the exact same thing to the other side to keep it balanced. So we subtract 4 from the left. That gets rid of that adding 4. Gives us just x. We have to also subtract 4 from the right side. 11 minus 4 is 7. It gets us right back to that form that we started with, x equals 7. Now here we built this equation, or we watched the equation get built at least, so we knew how to take it apart. The trick with solving equations is to look at an equation that's already built, figure out how it was built, and then use that to figure out how to take it back apart. So we might have something like, let's do 11 equals y minus 3. To figure out how it was built, we find the equal sign. We identify what side the variable's on, that's over here. Then we ask ourselves, what is keeping the variable from being by itself on that side of the equation? And in this equation, that would be the 3. And we also have to ask what operation is attaching that to our variable. Well, here that 3 was subtracted. So when this equation was built, what was done to the variable, what was done to y, was 3 was subtracted from it. So to take it apart, we have to do the opposite. The opposite of subtracting 3, of course, is adding 3. But again, we have to do exactly the same thing to both sides, or the scale is going to get out of balance. So we do 11 plus 3 is 14. On the other side, the plus 3 and the minus 3 cancel out, so we're left with just y. So we are at that form of a variable equals a number or a number equals a variable. We have solved that equation, 14 equals y. Now, if we're not sure of ourselves, if we want to double check it, we can go back to the original equation and replace the variable with that value, like we did when we evaluated expressions before. So 11 equals, instead of y minus 3, it's going to be 14 minus 3. 14 minus 3 is 11, so we get the same value on both sides. So we might get 7z equals 42. So do the same thing. Here's the equal sign. My variable's over here. The 7 is what's keeping the variable from being alone, and it is multiplying the z. So when this equation was built, what was done to z was it was multiplied by 7. Take it apart. Well, the opposite of multiplying by 7 is going to be dividing by 7. Again, making sure we do the same thing to both sides. Keep that scale balanced. So it cancels out the 7 on the left side there, so it's just a z. On the right side, 42 divided by 7 is 6. Well, so far, all those equations were pretty simple. They'd only had one thing done to them. They were what we refer to as one-step equations. Let's take a look at this one. (2x minus 7 equals 11). So now here's our equal sign. Variables on this side. Now there's two things keeping our variable from being alone, the 2 and the 7. Well, the 2 is multiplied and the 7 is subtracted. So if we ask ourselves what had to happen first, well, order of operations says we multiply before we subtract. So if x were a number here, the first thing that would have happened to it would have been multiplied by 2. Then the 7 would have been subtracted from it. Now, if you think about just put something together, whether it's a piece of furniture or a model, a toy for your kids, whatever it is. You've just finished. You've just put on that last piece. If you need to take it apart again, the first piece you're going to take off is the last piece that was put on. So here, when we go to take this apart, the subtracting 7 was the last piece that was put on. That's going to be the first piece we take off. So to remove subtracting 7, we're going to add 7. So the minus 7 is gone there, leaving us with just 2x. We had to add 7 on the right side. 11 plus 7 is 18. Now we need to get rid of the multiplying by 2. We'll do that by dividing by 2. So dividing by 2 removes the 2, giving us just x. 18 divided by 2 is 9. Well, again, if we want to double check, if we want to be sure of our answer, we can go back to that original equation and replace x with 9. Make sure it works. Make sure we get the same value on both sides of the equation. So 2x minus 7 becomes 2 times 9 minus 7 equals 11. So the right side is just going to be 11. There's nothing to combine there. On the left side, 2 times 9 is 18. 18 minus 7 is 11. So we got 11 on the left side as well. So if we have 38 equals 5x plus 3. What was done to x here to build this? X was first multiplied by 5, and then the 3 was added to it. So to take it apart, again, we take off the last piece that was put on first. That's adding 3, so we take it off by subtracting 3, making sure we do the exact same thing to the other side as well. 38 minus 3 is 35. 5x plus 3, well, the 3 cancels out, so we just have 5x. Now we need to get rid of the 5. 35 divided by 5 is 7. 5's cancel out, we just have x. So 7 equals x. Any questions? Okay, time for you guys to try a couple in your notes. So 3x minus 5 equals 7. And (47) equals 4x plus 3. I'll give you a minute or two, then we'll go over those. So the first one here, we're going to add 5. Three x. The 5 minus 5 is gone. 7 plus 5 is 12. Then we'll divide by 3. X equals 4. Second one over here, you need to subtract 3 first. We have 44 equals 4x. Then we'll divide by 4. Get 11 equals x. Any questions on those? Well, of course, they don't stay that simple. We can have extra pieces that come into play. One would look like this. So here, we find our equal sign right there. We go to identify where the variable is, and we look at that left side, and we realize the variable appears twice on that left side. Well, if we're still looking at these equations with that idea of being a balanced scale, the 5x and the 2x are both on the same side of the scale, which means I can go ahead and just push them together. 5x and 2x make 7x. Still have the positive 3 there. And that will not change the balance of the scale. It does not change the equation. So when we are going to solve an equation, before we solve, one of the things that we sometimes have to do is to combine on each side. Excuse me. Now that we've made that combination, well, this looks just like the last equations we've solved. We'll subtract the 3. 7x equals 14. And we'll divide by 7. X equals 2. This one looks very similar. Well, with one very significant difference. We find our equal sign right there. We go to identify where the variable is, and we see it appears once on each side. Well, if we're thinking of that balanced scale still, we can no longer just combine the 5x and the 2x because they're not on the same side of the scale. If we tried to combine them, it would change how this balanced. So what we have to do is get rid of one of them. Usually we get rid of, well, what we have to do, up here we had to combine on a side. Here we have to make sure the variable is on only one side. Here, since the variable is on both sides, we get rid of the smallest one. So the smallest one here is the 2x. It's positive, so to get rid of it, we're going to subtract it. Minus 2x makes that go away. That'll leave us with just the 18 on the right side. Now we have subtracted 2x from one side. We have to do the same thing to the other side. On the left side, the only place we can subtract 2x from, remember when we add or subtract, we have to have the same name. So the only thing we can subtract 2x from is from the 5x. 5x minus 2x, 3x. And we have the plus 3. Now we can go ahead and solve. We're going to subtract 3. Makes that go away. We have 3x equals 15. Then to get rid of the other 3, that's multiplying x, we're going to divide by 3. X equals 5. And just like any of our other equations, we can always go back to the original equation, put in 5 for x, and see if we get the same value on both sides. 5x plus 3 becomes 5 times 5 plus 3 equals 2x plus 18 is 2 times 5 plus 18. On the left side, 5 times 5 is 25 plus 3 is 28. On the right side, 2 times 5 is 10 plus 18 is 28. So when solving equations, first thing we have to do is combine what we can on each side. Second thing, to make sure the variable is on only one side. Once we've done those two things, then we can solve. I'm going to have you try a couple in your notes. So 3x plus 17 equals 5x plus 9. And that one. I'll give you a couple minutes to solve those, then we'll go through them. So for the first one here, there's nothing to combine on either side, but there is a variable on both sides. So we need to get rid of one of them. The 3x is the smaller one, so we're going to subtract 3x. So I got to subtract 3x from the other side as well. So on the left side, I just have 7. On the right side, 5x minus 3x is 2x. And I have the negative 9. Now we're ready to solve it. I'm going to add 9. Got 16 equals 2x. And divide by 2. 8 equals x. For the other one, we have the 3x and the negative 5x on the same side. 3x and negative 5x make negative 2x and a positive 28. So we combined what we could on either side. The variable's already on just one side, so now we can go ahead and solve. We're going to subtract 28. 14 minus 28 is a negative 14. We have negative 14 equals negative 2x. Then we divide by negative 2. Negative 14 divided by negative 2, and negative divided by negative is a positive, so that's a positive 7. Negative 2's cancel out on the other side, giving us just x, so 7 equals x. So for our first hour here, I got a little homework for you. This is all out of the big book. Page 442, 443, the unit exercises, 1 through 71, the odds. And then page 448, exercise 15-1, 7 through 35, the odds. And page 451 through 453. Exercise 15-2. 7 through 15, the odds. So there's about 17 minutes left in our first hour of class here. We'll give you that time to get started working on those.